Often all you're told about scientists is they wear a white lab coat and they're in the lab, and I knew that wasn't for me. I'm a people person. I need to be out there interacting with people, feeling like I was making a difference on the ground. So when I saw that the Global Challenges degree offered that side of it, where you have your impact through science as a specific unit you do every single semester, I was in love straight away.
I came here with Mum and did the whole tour as you do in Year 12. We're like, that actually looks really good. Like, it shows you that you're going to be learning skills and, applying these skills in a proper setting and changing things.
The more I read about global challenges, the more I realised that that was exactly what I was after, because I was interested in science, but I was also interested in international development and this urban planning.
I came into this course having no idea what I wanted to do, and that's what drew me to it, because I knew that I was really passionate about science and this idea of being able to use science as a vehicle to make change and use it in different contexts. I was like, yep, that's me.
Our supervisor, John Warner, is a very passionate guy, and he came to us with the brief of ocean plastics, and that was it. We kind of came to the conclusion that microplastics were the thing to work on, because that's kind of the big emerging field and consequence in ocean plastics. They get down to, microns in size, and anything can eat them at that point. Plankton, tiny fish, and then something will eat those plankton and those tiny fish. And they'll, travel up the food chain and accumulate in bigger and bigger animal stomachs until eventually they get to us. So we've found microplastics in seafood, we've found them in beer, we've found them in honey.
It's very much at that front end of things, looking at, well, what's the situation on the ground? What do these little bits of plastic look like? And what information that we get there we could actually use to create our solution.
We don't really know a whole lot about microplastics in the environment. We don't know what their properties are. We don't know if they're charged, how big they are, whether they're polyethylene or polypropylene or polystyrene, and what that distribution is.
We've been working on methods for detecting polymers and microplastics in rivers and streams, and trying to use a spectroscopic technique, so basically a detection technique, to see if we can get those polymers in a sample and kind of characterise those.
In the urban streams, so the little creeks and rivers around Melbourne, what those bits of plastic are in terms of polymer type, what size, what particle type. Are they fibres of our clothes? Are they little bits of chip packet?
Some polymers can fluoresce, so when you shine a light on them, they kind of like shine a light back at you. And that seemed to be the most kind of promising technique, and something that we could actually make from a kind of like a lab scale instrument into something that could be handheld and actually used in the field.
I think we were successful in really diving into the option of using fluorescence spectroscopy and starting to realise that could actually potentially be used, and it's very easy to miniaturise, could potentially be used to detect some types of plastics as well.
People just don't have an understanding of the microplastic problem and the extent particularly of the microplastic problem. And from the teachers that we've spoken to through a series of interviews, they have been like, wow, like this is huge. This is something that we need to be talking about in our classrooms. These are the barriers that we think there are to implementation. And we've been working on solutions to try and overcome those. If you told me a few years ago I'd be majoring in soil science, I would have been like, Dirt, are you serious? Let me leave now. But just by following things I was interested in, it really drew me towards soil science and agricultural science. The idea of using a satellite to identify soil properties is being looked at worldwide. Precision agriculture really wanted to find out more about this new technology that people were talking about, because they want to provide information to their customers, but they really want a scientifically rigorous approach. So from a satellite, you can get a reading of the greenness of the crops and plants across the whole world, essentially, but zoomed that all the way down to a farm. The resolution of the imaging we were using was 10 to 20 metre, so it's actually quite zoomed in. And so the information we were looking at in DVI looks at the difference between infrared light and near infrared light. So it's not all in the visible spectrum, and it's the difference between those two lights that gives us the information we need to tell the greenness of the plant. What we chose to do was take that data that we already had and compare that to the satellite imaging. I didn't have to go out into the field and dig up a hole and do all the soil sampling myself. I was able to have a large range of data. So in the end, we used 6 different farms with 29 different paddocks in total across central New South Wales. When I presented these findings to people working in precision agriculture, their response of how valuable that research was to them really made me realise how valuable my work was, because it wasn't that I didn't find something, I just found something that didn't work. So it's made them believe more strongly in grid soil sampling and their current methods. Doesn't mean they're not going to continue looking at new technology, but they know now that this probably isn't the right path for them because it doesn't have that scientific backing or consistency.
Agriculture Victoria gave us the task of reimagining the dairy waste industry. There's a bit of a disconnect between the farmers' thoughts and what the science says. So a lot of these intensive farms don't actually realise that they have a nutrient surplus problem. However, it's going to lead to future impacts to our groundwater, contaminating groundwater, as well as runoff into the natural waterways.
As dairy farms become more intensive, we're looking at being able to take the manure off farm and put it into other farms or other industries such as crops or land rehabilitation or veggie growers, and basically spread out the nutrients a bit more so that they're not too much in one place.
If we've got too many nutrients on the land, how can we get rid of it? So let's try to do something with the poo.
My name's Tom Carney, and let me show you my honours experiment part 1, which is making our own incubator to grow some black soldier fly larvae. Temperature's been holding up well, but I just wanted to illustrate, I guess, the crusting, or what I'll call the apple crumble effect that's happened on these, I guess, pellet and liquid manure mixes. Whereas we compare that to chocolate pudding effect, but it's got a nice crispy layer on top. Add the bugs and should be good to go. Once we turn this over, it's absolutely heaving.
These particular maggots are meant to be able to grow quite quickly. If we can vastly reduce the mass of the manure, the output of that being a fertiliser would be hopefully more concentrated for transport, and then these maggots being, I guess, a form of protein and fat that can go into aquaculture feed, and I know some people even want to put it into human circulation, was, I guess, the option that we're going for, was to be able to condense that manure. Because we've got a voluminous mass, how can we make it more valuable?
We found that if they were to get it off their farm, that it would be because they were getting paid for it, or because it reduces their labour, because that's the biggest thing for farmers, labour and money. They are enterprises, and that's what they want to make.
The main thing that I was working on for second semester was the market research. So it was looking at the people who are actually going to use the manure, so land rehabilitation, veggie farmers, crop farmers.
The new regulations put a lot more emphasis on farmers to classify their waste, and it also means that people receiving the manure would have some requirements. If we had an online platform, this could enable the automatic classification of the waste, tell farmers and, I guess, help them be compliant with the regulations, whilst also being that marketplace where they can find people to send their manure.
One of the things that I said I was interested in was sustainability, so that's the bit that it most feeds into, the idea of reusing materials and making most of the resources we have. The thing that I most connected to in this project was a bit of the technology side around the anaerobic digestion, but also a bit of the circular economy.
I grew up in a country town of Maffra, so that's where my passion for this project came. Although I had to understand the farmers and where they were coming from to find their incentives, at the back of my mind, I was really driving for the environmental challenges that the community was facing.
We were developing a species monitoring system for insects and rodents. The idea started in 2018 by a Global Challenges team who developed a technology called supersonics. And I guess the idea behind that was that the eyes of nocturnal animals have a special structure that allows them to see at night. So when you shine a light into those eyes, the intensity of reflected light is really strong, and that's what they call eye shine. So we were basically using that theory and applying it to insects and rodents, except that they don't have a predetermined eye shine that anyone's found before. So we were trying to develop a novel system for detection of those animals.
Think of like a little bee that's actually got a camera in it and it's linked to wireless systems flying around in the environment, in the field, and you could image different insects to tell you what type of insect they are and how many there are, and obviously because of GPS, where they're located. So it could be a way to count insects in the field, to keep track of insects that are endangered, but also more immediately, so that's the big idea, more immediately for pest management.
We started by trying to develop equipment that was sensitive to both UV and IR radiation because we wanted to do it in non-visible wavelengths because we thought that there might be something there that was species specific.
It was all about selecting the right equipment for the job, trying to put it all together in a way that was feasible and then testing it, and obviously things break and then you have to prototype and iterate. But by the end we found that we were working very closely together.
I was looking at insect eye specifically, and if there were any differences within the eye structure, such as eye size, like the distance between the two eyes, and insects have this really cool simple eye which is called a dorsal ocelli. And I was using those features to see if I could classify the insects according to species in first semester. So I worked with dead insects at the start. I was actually very successful. So I worked with moths, butterflies, wasps, stick insects, and I could create like this PCA, which is basically just a fancy map with clusters of the different insects, and very amazingly they didn't intersect, which meant I could find a way to classify them based on these features of the eyes.
We had to find a camera system that could actually capture UV and infrared radiation. So there are two ways that we tried doing that. One was a mechanical means and one was a chemical means of making these cameras sensitive to UV and visible wavelengths. And neither of those methods really worked, but it allowed us to say, okay, now we can use a monochrome camera because that is actually sensitive to non-visible radiation.
In the last week, we had kind of a breakthrough with this idea of using this internal component of a camera that we've been spending basically a whole year trying to remove, that you could actually keep that in there and utilize it in order to be able to take infrared and ultraviolet measurements of an animal simultaneously. And it just goes to show with research that you can spend a year or many years trying to do one thing, and then that leads you to something entirely different from where you started off.
There's actually a new strategy that's been implemented across all the cities and councils in Melbourne called the Living Melbourne Urban Forest Metropolitan Strategy, and that is based on improving the green space and urban canopy across the whole of Melbourne to improve livability. And the City of Casey had signed on to this new strategy, and so that was our project, is helping them to understand what would be a good place to start and what they could do to improve their urban forests.
We looked for priority areas for tree planting, and so my project was on heat vulnerability and urban heat islands, and using that information to find out where to plant trees.
There was this conversation within the council that council members were having kind of, I guess they had a biased opinion of how the community perceives trees because all they hear about is complaints, and which common sense tells you, well, that's not true. We know that everyone really likes trees and we know all the benefits that they have, so how can we showcase that to the council?
I collected thermal readings from NASA and then I transformed them into temperature and mapped all of the different areas in Casey using the temperature readings. And so it showed up different areas that were really hot or really cold, and we found that the middle section of Casey was really, really hot, whereas the outer areas were really cold. So I made a map of all of the urban forest in Casey, and I made it interactive so that when you click on a little icon, which was a tree, then it would pop up with the genus type and the age of the tree as well.
Peace and the solitude that I get from them, especially in this park here. With the birds, I can just sit here.
I really enjoyed the filmmaking. I especially enjoyed the community video where I approached community members and I just asked them, well, why do you love trees or why do you think they're important? I had people talking about how they've moved country 6 times and they really struggle to make friends, and trees were their only friends.
It gives life, colour, and it feeds animals.
I decided to do my project on green space and accessibility in my research project. And I thought that was a good thing to be looking into because it is dependent on all the socioeconomic factors in the area. And so I was investigating those to see if Casey could be improving on their green space accessibility or if they were meeting what the standards that they should be meeting.
The day our thesis was due, the council put up some of the content that we created as well. They didn't tell us, they just did it, which was exciting to go on and see a nice surprise there.
And I can really see a lot of passionate people within local government that are kind of almost restrained by policy. So if you can figure out a way to kind of remove as much of red tape as possible, some really amazing things could happen.
To come and we play in the shade and they're good for the fresh air. That's very important for your future.
We got partnered with Pacific Bio, who bioremediate water with algae. So they get an algae in a big sort of circular pond and they pass nutrient-rich water through it. All the algae needs, it's just like a plant. So it needs sunlight, oxygen, carbon dioxide, and nutrients to grow. And the reason it flourishes in these rich wastewaters is because those nitrogen and phosphorus compounds are limited in the environment usually. When they're in high concentrations, they take advantage of that and flourish. We got to go to Queensland at the start of the semester. So we did a trip there just to sort of physically feel the algae, to see how the ponds work. We basically looked at all the different industries that they might be able to tap into. So dairy manure or municipal waste. And we assess those opportunities based on a sort of a ranking matrix. Is there space to do it in the facility? Does the market have the money? Is there a problem with the effluent?
We did a lot of research figuring out the wastewater characteristics of mining, of energy, and we looked at all these different small markets, and we pretty much developed a methodology, an algorithm, which created a ranking for that, and then we looked at how feasible is that wastewater with the technology. And once we developed those characteristics, we kind of merged those two points together and we got an overall ranking score. And when you got to the top of that list, you got meat processing wastewater. A lot of wastewater from abattoirs, it has high nutrients, so it has high nitrogen and phosphorus content. So if that gets into ecosystems, if that pollutes water, you get these massive algal blooms which can destroy ecosystems.
They have to clean down the facility every day. They have to clean all the equipment. It's just sheer amounts of wastewater. And that's why abattoirs, again, it's got a huge market size because it's just got such a sheer volume of water.
When you speak to people that are operators and owners, their priority is really about the meat processing. It's really about getting produce and selling it. But with compliance being such a big issue within Australia for farmers and for operators to make sure that they're doing it right, they actually had to start listening to us, and we got a chance to speak with Peak Body Industries, the Meat and Livestock Association, the MPC, the Australia Meat Processing Corporation, and through that we started developing relationships with them, and they said, oh, we have a few different research trial projects that you could possibly look into, and that kind of was really exciting because it provides the company with next steps to actually implementing pilot trials with industry in the near future.
Currently, with the reporting mechanisms for when an instance of sexual violence occurs within aged care, it's not actually included if it's not reportable to the Department of Health if the perpetrator is a other resident with a cognitive impairment like dementia.
Almost half of people in residential aged care have dementia. These people are not getting the dignity of and the I guess the attention of having a report made for them once they do disclose an event of sexual assault on them.
They might need to access a lawyer, they might need to access a safe housing option, they might need to change aged care facilities, they might need to get a forensic examination, they might need to see a doctor to get an STI test, they might need to see a trauma counsellor, and the list just goes on and on and on. And we're expecting people that have experienced a really awful trauma, who might already have a cognitive impairment and other physical disabilities, to then go and figure out themselves all those people to call. We initially created the 7 recommendations with a panel, going through what the key problems were, what some ideas were. Then we went away, got them into a 10. Then we presented them at a seminar where we got feedback on them, who were mainly aged care workers. And then we kind of funneled them down and fixed them a bit, and then took them to Canberra, where we presented them to different politicians from 6 different political parties. And so there is a lot of disbelief, but we were never ever met with that doesn't happen. And I guess that's the first step to creating change.
I think it's important to be advocates for a group that doesn't necessarily represent what you are now, but we're going to be old one day too. And I'd hate to think that my parents, or even, if this thing goes on till the time that I need to be in aged care, I'd hate to think that I won't have the voice then, but I've got the voice now.
World Mosquito Programme's method involves releasing this one mosquito called Aedes aegypti, and it has this Wolbachia bacterium in it. And these mosquitoes actually prevent the transmission of dengue, Zika, chikungunya, and other viruses. A large part of their intervention is to track how those mosquitoes are spreading across the population. The only way you can do that is by capturing adult mosquitoes and then testing those adult mosquitoes for the presence or absence of that bacterium. Our aim was basically to find ways that the World Mosquito Program can scale up their method, so kind of working out low-cost options, trying to see which options are more transferable for communities. So we were looking at international project sites and focusing particularly on Fiji.
My particular role was looking at what components of the Wolbachia method can be run by local partners. How can they transition to more of a guiding franchising model to empower local partners? So I was doing interviews with stakeholders in Fiji. That was sort of what we were doing as a case study, and also testing how can we enhance egg translocation.
Unlike Taneo and Joe, who were out on the sunny western side of Fiji, I was in Suva the whole time, and so I was set up in the office space, and I essentially just had a wooden desk, and I'd set it up with all my lab equipment. And so it was a non-sterile lab, just in the same working space as everyone else. And I was conducting at least one new test like each day. And so I was just building up the procedure and then making sure it was accurate. And towards the end, I was getting all the staff involved in testing. A lot of the modifications ended up coming back to cooking. The first one was, how do you mash up mosquitoes without a machine that shakes it back and forth with the plate?
I went down to local shops and tried to find really cheap alternatives and put together a low-cost aspirator. So a boat fan, just a bunch of PVC pipe and just basic electrical circuitry, and just glued them all together, hammered them together, and then that basically made the low-cost aspirator. So my research then in Fiji was testing that against the commercial device. It actually performed really well. So the mechanism was pretty much essentially the same in that it sucks in mosquitoes. There's not too much difference, and they were similar in size. And the low-cost aspirator ended up catching equivalent number of total mosquitoes. It was tested across the west region of Fiji, and so we went to 352 houses and tested both devices.
I was using beetroot peel as an attractant and compared that against what is the standard in Fiji, which is chicken feed pellets. And the beetroot peel actually outperformed almost by double the chicken feed, and it actually caught less of our non-target species of mosquitoes. So that finding is going to be retrialled for WMP in Mexico.
The first kind of people we engaged with had all had personal experiences with one of the 3 diseases that the mosquito carries, and so it was quite an awakening to just realise how pervasive and how much suffering comes alongside of the disease. And it's kind of quite insulated just sitting here at Monash, but actually being over there was quite a different story.
Don't let yourself get comfortable, always challenge yourself. You need to be fierce and go after opportunities and make sure you're always learning something.
I've seen both from myself and from other people in the course that even just trying out one particular opportunity that may come up may develop into a pathway.
I'm going out of the course with no idea what I want to do, and I'm perfectly happy with that. I wouldn't have it any other way. I feel like I'm in a position where I've got lots of options and the skills to adapt to different options as well.
Trying to understand how we can better convey science. I want to do it because I think it's really important, especially as we head into a world where science is distrusted more and more.
Trying to help people and trying to enact good in the world. And I think that's the reason that I entered this degree, was to learn how to do that more effectively.
I love tangible outcomes. I love seeing something I've created. And I think that's what I didn't really appreciate science was able to do until I started the degree.
The people you're surrounded by are also doing, pretty cool research and impactful research and very passionate people. And through those people you meet other cool, passionate, impressive people. And it makes you realise that, while there's a lot of people out there that are causing a lot of problems and that are standing by and watching those problems get worse and worse, there are also a lot of people doing their best to push back on that.